Hi everyone, this lesson is going to demonstrate the solution of question 8 from the Tech Active part of the Sample IA2 exam. So let's go. Terry is an avid skier. The equation that models his favourite ski run, now that'll be important, is given by this formula here. H is the height in kilometres above sea level, that sounds like a vertical axis. X represents the width of the run, cross-sectional width, so that's horizontal, cross-sectional, yep. The run terminates at a place 1 kilometre above sea level, and then the cover of snow on the mountain is 2 metres, assuming constant. The run is 300 metres wide, and importantly, we need to calculate the volume of snow on the run. Okay, Tech Active question. My first thing to try and make sense of this will be to do a graph. So I'll go to the graphing app. I've already entered the equation here as per from the question, so we'll draw that. And there's the graph. Now it says we terminate 1 kilometre above sea level. So 1 kilometre above sea level is about here somewhere. I might just zoom in a little bit, and I'll use a box this time. So I get to set the left and right corner of the box. So I might just go a little bit that way. I'll press enter to lock that one in place. And now I'll come across a bit, and then I'll come down. That should be enough. So there's my ski run, and I'm looking for the point here. So I can do that with GSolve, and then it's an X calculation. I'm going to give it a Y value, and I want the machine to calculate. So the Y value is 1, and there's my X value. It's 1.1499. I think I'll just call that 1.15. So I'd better start to write something down. Oh, what happened to my page? Let's just refresh that. There it is. So here we go. What would I write for the examiners to convince them that I know what I'm doing here? Well, I'm going to sketch the graph. So the graph curved downwards like this. That was the value of 1, and then that value there from my calculator screen was 1.150 if I round to 3 decimal places. And that's using technology. So I would have to make a note that I did a GSolve. So I'll say using, I did GSolve, then I pressed, let me go back and check that because I don't remember what I pressed. I went GSolve, then I went xcal, and then I gave the Y value of 1. That's what I did. And there it is. So I did an X calculation, and I set Y equal to 1. And so the calculator then told me that X had the value of 1.150 kilometres. They did note that these were all in kilometres. So now what are we looking at? Well, we've got snow covering the ground. Sorry, I tried to make that blue then. We've got snow covering the ground to a depth of 2 metres. Now I've greatly exaggerated that, of course. And then the width of the run is 300 metres. So I've got this great big sort of weird shape like that. It looks a little bit like a rectangular prism that's been bent to follow the curve of the ground. And I've got to find the volume of this thing. Well, if I was to find the area of this edge, that surface area there, that would be like the base of the prism, because there would be, if I sort of try to draw in the hidden detail at the back there would be a shape on the other side, which is the same shape, and that would be the top there. So that I could consider the shaded part to be the base of a prism, and then I could just multiply by the 300 metre width, that's 300 meters wide, but this is the bit that I'm going to have to use calculus to find. I'm finding the area between those curves, aren't I? Now, I've really got two functions there. The first function is given by the formula. The blue line that's above is literally just going to be adding on 2 meters to that, isn't it? So let's write my functions. So my first function for the actual ground is the one that was given, 1.8 times e to the negative x plus 0.43, I think it was, 0.43, and I better label my function there on the graph as f of x, so the examiners know what I was saying. Now I'll have a different function, g of x, that's this one at the top here, and literally it's the same formula with an extra 2 meters of height. So it'll read 1.8 by e to the negative x plus 0.43. Now this is a trap. If I was to write 2 there like that, I'm adding 2 kilometers worth of height because the question said these formulas were working in kilometers. So 2 meters measured in kilometers is adding on 0.002. There we go. I want to find the shaded area. So I would need to find, so the area between the curves would be the integral from 0 to 1.150. There's my limits of integration. And it would be the top curve, that's g of x, subtract the lower curve, that's f of x, integrating with respect to x. Now it should be pretty obvious. If I take this big blue formula and subtract the black formula, everything disappears except for that 0.002. That's the leftover bit between the limits of 1 and 1.50. So the integral of that will be 0.002x from 0 to, sorry, typo, 1.150, and we'll substitute this in. We'll have 0.002 times 1.150 minus 0.002 times nothing, so that bit doesn't matter. And this is from the calculator, isn't it? The calculator will help me. So I will just pop back to my menu screen to perform this calculation, and it's 0.002 times 1.15. 2.3 by 10 to the power negative 3. 2.3 by 10 to the power of negative 3. That works. And that would be in square kilometres, because these were all in kilometres. Now that just gives me the shaded area at the front edge of this sort of a curved prism shape. To get the volume of the prism, I'll need to multiply by the constant 300 metre width. So here I go. Volume would be the area of the base by the height. That's like a middle school formula, isn't it? So still applies. 2.3 by 10 to the negative 3. And again, if I write 300, I'm consistent with my units. So in kilometres, 300 metres is 0.3. So let's multiply by 0.3. And we get this really small answer, 6.9 by 10 to the power negative 4. Put that there first. 6.9 by 10 to the power negative 4. So this is in cubic kilometres. There it goes again, in cubic kilometres, which is a pretty inconvenient unit, I must say. So let's see if we can do something a bit better here. Whoops, that should be a 9. by 10 to the power negative 4, and we have cubic kilometres. Now what I really want to do is introduce a conversion unit with kilometres in the denominator, so it cancels, and metres in the numerator. Now, how many metres is the same as how many kilometres? Well, 1,000 of them is the same as one of those. Now, that's not going to be quite right yet, because I've got a cubic kilometre and that's only a normal kilometre, so I'd better cube this thing. If I cube this thing, then I'll have the right idea. So I'll show you what I mean. 6.9 by 10 to the power negative 4, still cubic kilometres for that number there. Now, 1,000 metres cubed. Well, what's 1,000 cubed? Well, we don't have to work that out, we'll just write it like this, but it's now got metres cubed as the unit. What's 1 cubed? Well, still 1, and it's going to have the unit kilometres cubed. So those units cancel the way we wanted, and if I multiply these numbers together, I will now have my answer in cubic metres. A much more sensible unit for this. So let's go multiplied by 1,000 cubed. And I get this number here, 690,000 as my answer. So that's 690,000 cubic metres of snow covering the ski run. Let's check to see that we've answered the question. It was calculate the volume of snow on the run. Done so. And we've used the appropriate units and we've justified our solution. So that's it for this video. Thanks for watching.